Why model? Well, there are a few different ways in which one could answer this question, so let me break it down into two parts. First, why should you or anyone model? And second, why do I model? To answer the first one, I think it is useful to ask why not model? And here the answer is clear, as I am not sure if one can at all do any science without modeling. To better understand what I mean, let's look at the general outline of a scientific method that goes back to Sir Isaac Newton. The scientific method starts with the outside world, the reality, and different things happening there, like companies entering markets and competing and learning and adapting and so on. And the researcher at some point looks at all of this world and says, that's interesting, I wonder why this is so. Then, the next step in this process would be to formulate some tentative explanations, like companies enter because the industry is attractive, or maybe organizations enter because other organizations are entering as well. With a given model, we can generate hypotheses. For example, if that model is right, then we should observe the following, and so on. Coming up with those abstract representations of reality is in fact modeling. Then we go back to the world, we collect data or run an experiment, and we either reject or fail to reject these hypotheses. Now, without modeling, where we try to postulate what the data generating mechanism could be responsible for the behavior observed, we cannot do science. So why model? Well, because without modeling, we would not be able to do science. And I think it really goes back to that question. Now, it is important to mention that modeling is not only done with numbers or with a computer code. Modeling comes in multiple types. There are verbal models, where sometimes author just writes what they wanted to represent. Sometimes authors use boxes and arrows to capture the constructs and relationships more clearly. We can also use closed-form modeling, where we have equations that can be proven and so on. Then sometimes we have those weird hybrids where there is math but still some normal English language. And finally, we can use computational modeling, which kind of brings us back to the second part of the question, which is why do I model? In my research, I particularly focus on the computational models. This is because I'm interested in phenomena which view organizations as complex adaptive systems that learn, acquire capabilities, and respond to the changes in the environment. These organizations learn from the environment, and they learn from each other. And to better understand these type of processes, computational modeling is particularly powerful, as it allows to be very precise about what type of mechanisms and concepts are responsible for the observations in the real world. So one can say that at the end, it may boil down to personal preferences. And there is some truth to that. Some put more emphasis on internal validity or how well their propositions flow from the assumptions than on external validity or how much of the reality my model captures. Models by necessity are simple representations, so they do lose lots of the detail and thus will appeal more to those who value internal validity. So because science is a team sport and it requires theorizing and experiments and empirical work, I find myself drawn into modeling, and this particular type of research resonates with me. So that is why I model.